all heard of manure being an effective fertilizer. After all, cattle, chicken, and horse manure are all common fertilizers used. However, did you know that urine is just as rich in nutrients, especially in nitrogen, which is a crucial component for fertilizers? Recovering the nitrogen from wastewater can both help reduce pollution and contribute to building sustainable agriculture. But why is this important? Let's first understand the importance of nitrogen. Nitrogen is a key component of plant growth found in both proteins and DNA. It makes up some key components like chlorophyll and amino acids. The nitrogen cycle consists of nitrification and denitrification, which help regulate the levels of nitrogen in soil. As we know, nitrogen in its natural state exists as N2 gas. However, plants are only able to use nitrogen in its forms of nitrate, NO3, and ammonium, NH4. But what does this help us understand? Because ammonium has a positive charge, it's able to bind with negatively charged soil particles, which help keep it in place when it's in the soil. Nitrate, on the other hand, is negatively charged and is highly soluble in water, meaning when it's in the soil, it's able to easily move around with water. Ammonium is incorporated into proteins and amino acids, and nitrate is used in chlorophyll production and protein synthesis. Let's move on to nitrification. Nitrogen recovery begins with nitrification, which aerobic reactors can help us with. Aerobic reactors are devices that help treat wastewater, requiring the presence of oxygen to help break down organic matter. Nitrification is the two-step process of bacteria converting ammonium into nitrite and then into nitrate. As I mentioned before, oxygen is required, but so are nitrosomonas, which are the bacteria that convert ammonium into nitrite, as well as nitrobacter, which are the bacteria that convert nitrite into nitrate. So, our reactions would be ammonium combining with oxygen to give us nitrite, water, and hydrogen, and our second reaction would be the nitrite reacting with more oxygen to give us nitrate. So the first reaction would be the nitrosomonas oxidizing the ammonium to give us nitrites, and the second reaction would be the nitrobacter oxidizing the nitrite to give us nitrate. Although these treatments are much more environmentally friendly than recovering the nitrogen from the air around us, the use of aerobic reactors still releases greenhouse gases like methane and nitrous oxide. Although nitrous oxide is a particularly potent greenhouse gas, careful management of the aeration and treatment process can help minimize these emissions as much as possible. Because the nitrogen recovered from wastewater can be used directly as fertilizer, it helps create a circular process where waste is turned into a new resource. For example, 1 cubic meter of treated urine produces enough nitrogen to fertilize several hectares of crops, like tomatoes. The nutrient recovery from wastewater isn't just a chemical process, but also a valuable step towards a more sustainable future. Recovering nitrogen can reduce our dependence on synthetic fertilizers, lower greenhouse gas emissions, and even contribute to more local food production. The process not only creates valuable resources, but it closes the loop between waste and crop production, contributing to a more sustainable future.